All right, good morning, everybody. So yesterday we talked about logarithms, and today we're going to continue talking about logarithms, but we're going to look at their graphs. So what we need to know is that logarithms and exponentials are opposite, so like inverses, okay? So before I do anything, 1117, I want to put down that we know that exponential, if we have some base to some x equals some answer, its inverse is a logarithm. Log of some base of my answer is equal to my x. Okay, they're inverses. So if I take a look at graph number 1, and let's change this to y equals, it is a function, but y equals a 2 to the x. You can actually put this on Desmos. Okay, so if you have Desmos, I did an e here. If I do a y equals a 2 to the power of x, it looks like that, okay? And it is exponential. Some of the things I know about this graph, though, I know, for instance, anything to the 0 power is going to be 1, so it has to go through 1. We could rewrite this as a y equals a 1 times a 2 to the x, so we know the y-intercept must be 1. And doubling to my base is that's my base. And my base is to double. Okay. So if my base is to double, let's double. Okay, so I've got 1, I double it to 2. Well, let me use a different color. Double it. And if I double 2, 1, I get 2. If I double 2, I get 4. And then I double that and I get 8. 1, 2, 3, 4, 5, 6, 7, 8. On the backwards, I'm going to take, and I know I doubled it, and it came from 1/2, 1/4, 1/8. Okay, and we know that if we graph this in, looks like that. Okay, it has a horizontal asymptote, which we've talked about. It has a horizontal asymptote right here at y equals 0. So I'm going to write that into. Okay, so I've got my horizontal asymptote at y equals 0. There's my horizontal asymptote. Now, e to the x, you can actually do this also on Desmos. It took me a while to figure it out, but I did figure it out. So I'm like, wait a minute, it's got to be able to do an e, right? So I went and I said, hey, there's an ABC. And I thought, well, what if that is really the number e? And you know what? It turned out to be, it turned out to be the number e. E to the x, and there it is. It looks like this. Now the two graphs look almost the same, except for the base is y equals, it's about a 2.7718 to the x, because remember, e is approximately equal to about 2.718, okay? So they're very similar. The only difference is it's going to grow a little bit faster. What I could do is tap some points to get some points along here, right? Well, my graphics calculator does a better job because it gives me a trace. I go y equals, clear that. Let's go clear that, and e to the x power. I'll show you what it looks like. It should look very similar. Graph it. Yeah, very similar. And on my calculator, I can actually do a trace, and then go, for instance, I can go trace, I can go 1, I can go 2. So it's very similar. 2, and I got about 7.8. 1, so it goes through here at 1. Oh, let me use a different color. 0. 1 is going to be about a 2.71, right? 2.71. I just did 2. It's about a 7.4 maybe. 1, 2, 3, 4, 5, 6, 7.4 maybe. And I get to do a trace of 3, and I get about a 20, which is way off the graph. So I know it looks very similar, except for it grows a little bit faster because the base is a little bit bigger, okay? So it does grow a little bit faster. Well, that's not a very good curve, but there it is. Horizontal asymptote, yep, it has a horizontal asymptote at y equals 0, okay? Range and domain, we know the domain for both of these is x equals all real numbers, right? And we know the range for both of them is y is greater than 0 because it never touches 0, okay? Now, y equals 2 to the negative x, because of the negative, this one's going to be, see the negative, it's got a negative in there. It's just going to be a reflection over the x-axis. So this is a reflect over x. Oh, that's not true, over y-axis, my bad. So it's going to look like this. 2, 1, 2, 3, 4, 5, 6, 7, 8, okay, and this one is going to be then decay. And you can put it in your calculator and check it, but you will get a graph that looks like that, okay? So again, if I wanted to put up my calculator, if I want to say, hey, Mr. Davies, are you sure? Do you really know what you're talking about? And yeah, I kind of do. 2 to the power of negative x, graph it. There you go, okay? Again, same thing, we're going to have a horizontal asymptote at y equals 0, okay? There's my horizontal asymptote. Now, domain and range are the same. Domain is all real numbers, right? X equals all real numbers because it's forever wide, and the range starts kind of at 0. It doesn't really start at 0, but it starts above 0, so it's y is greater than 0. Domain, range. Okay, thumbs up. Now, what we want to do is this. On the next piece is we want to graph its inverse, which are they going to be the logarithms. Okay, so let's first do 5, and then we'll come back to 4, okay? So to do 5, I'm going to take this graph, okay? And they're inverses. So I'm going to take a look, first of all, at if I had y equals 2 to the x, and I had these values, okay? So the points I had were, let's see, I had a plug-in -1, and I had a 1/2. I plugged in 0, and I got a 1. I plugged in 1, and I got a 2. I plugged in 2, and I got a 4, and I'll do one more if I plugged in, squish it over here, 3, I got an 8, okay? So that was my y equals 2 to the x. But if I want to do log with base 2, let's see, I'll inverse these. And so if I inverse these, I want to switch, inverse. We're going to switch x and y's because logarithms are inverses. So I'm going to go ahead and switch x and y. So instead of my -1, 1/2, I'm going to have a 1/2, -1. I'm going to have a, switch it around, I'm going to have a 1, 0. Switch the x and y's because it's an inverse, I'm going to have a 2, 1. Switch it around because it's an inverse, so I'm going to have a 4, 2. And switch it around because it's an inverse, I'm going to have an 8, 3. Okay, let's see what that graph looks like. Okay, so this graph is going to look like this. 1/2, -1. 1, 0. 2, 1. 4, 2. 1, 2, 3, 4, 2. 8, 3. 1, 2, 3, 4, 5, 6, 7, 8, 3. Now, this graph had a horizontal asymptote at y equals 0. It's an inverse, right? It's an inverse, so it's the opposite. So this graph, the log graph, is going to have a vertical asymptote at x equals 0. So we have a vertical asymptote. This is what Lauren asked the other day, right? At x equals 0. Okay, so my graph will never touch 0, and it looks something like this. Now, if it's an inverse, okay, if it's an inverse, then x becomes y, and y becomes x, right? If it's an inverse. So, I had a horizontal asymptote becomes a vertical asymptote, and the domain becomes the range, and the range becomes the domain. Meaning, take a look at this, my domain of this graph is going to be x is greater than 0. It never touches 0, but it's greater than 0. But the range is y is equal to all real numbers, okay? All right, now, your homework today is going to be taking these graphs and moving them. But last but not least, let's graph number 4. Now, number 4 can be done on a calculator. And I believe even Desmos will probably do it for us. I'm not quite sure. Let me check. Does Desmos have a log? I don't know. Functions, maybe. I haven't tried this yet. Functions? Oh, it does. Of course, it's got to have a log. Miscellaneous. Log. Log of x. Right? And there it is. Log of x. Now, it's a lot steeper than, and what you get is a point at 10, 1. You have to have a point at 10, 1 because it's base 10. We're still going to have a vertical asymptote at x equals 0. It's still going to go through 1 because anything to the 0 power, remember, it's the inverse of y equals 10 to the x. Anything to 0 power is 1. And then at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you'll have a point at 10, 1. So it's going to be a lot more shallow because as an exponential, it's much more steeper. And there it is. Okay. All right, so the homework today is going to be just simply manipulating these and moving these, okay? Hey, I think I saw something on your calculator too. That's kind of cool. I just learned something. I'll share it with you, okay? So you go to functions and miscellaneous, and then you can do a log of a base. Look at that. Cool. You can do a log of a base. I like that. So I could probably do log base 2 of base 2 of x, right? I may have to delete this one, go back over, and x. And this is one I graphed earlier. Yeah, there it is. Just a little bit steeper. Okay, so the homework today is just going to be taking these graphs, these parent functions, and moving them. So if you go to 4.3, you're just going to take your graphs. You're going to move exponentials. You can also try and use your calculator if you need to, because your calculator will do it. Your Desmos will. But you need to take a look at these graphs. For me, the most important thing is knowing the shapes, okay, and the domain and range. For me, the most important thing is knowing the shapes. Got the shapes of an exponential, and then shapes of a logarithm. Knowing the domain and range and where the asymptotes are. Okay, so that's what I have for you today. I will talk to you tomorrow. Well, maybe.